Actually, we're not going to have it with me stepping in here. Try that one again.
Well, I mean, I can just start it from any point. I can just cut it.
Alright, so tell me when to go.
All right, start.
Hey guys, today we're going to continue our study of ideal gases, and we're going to look at Chapter 5, problem number 36. So the problem reads, the temperature of 2.5 liters of a gas initially at STP is increased to 250 degrees Celsius at constant volume. Calculate the final pressure of the gas in ATM. Alright, so this is, first thing right off the bat, we know that we're going to be using PV equals nRT. Alright, now like the problems we've encountered in the past, this one's another one where we have two situations. We have an initial phase, and then we have a second stage afterwards. So let's say our initial stage, so let's call that stage 1. Alright, so stage 1, or we could say stage initial, and then stage 2. Alright? So, and we know at stage 1 we're going to have our pressure 1, so our P1, our V1, our N1, no R1 because R is always constant, and then our T1. Alright? And then at stage 2 our P2, V2, N2, and then our T2. Okay? So let's now look at this problem. Let's try to fill out this chart as much as we can. So the temperature of 2.5 liters of gas initially. So initially, stage 1, volume, 2.5 liters. All right, so V1 is 2.5 liters. Remember, liters per ideal gas law. All right, let's keep going. Initially at STP. All right, STP. This is a key part of the problem. So STP right here, what's that? Basically, that's a nice way of saying standard temperature pressure. Basically, when they say it's at STP, that basically means our temperature is 0 degrees Celsius or 273 degrees Kelvin. Remember, Kelvin, ideal gas law. All right, and then pressure is 1.00 atm. Okay? So gas is initially at STP. So we're going to fill that out for our stage 1 information. So P1 is 1.00 atm. Then our T1 here is 273 degrees Kelvin. Okay, let's keep going. So is increased to. So this is kind of our shift to our stage 2. So it's increased to 250 degrees Celsius. So that's a new temperature. So we have 250 degrees Celsius. But remember, we need it in Kelvin. So add 273 to that. And that gives us, let's see, 523 degrees Kelvin. Okay? Now let's see. Constant volume. Alright, that means our volume doesn't change. So V1 is the same as V2. 2.5. And calculate the final pressure of the gas in ATM. So what we're after is right here, our P2. Okay. So we look at this, so we have our stage 1 filled out, our stage 2. We need to figure out how are we going to use the ideal gas law to find this P2. Well, the thing is, we can't really start right off the bat with stage 2 because we have two unknowns. We don't know P and we don't know N. So we're going to have to use the information given in stage 1 to solve for N1, and then we know that N1 is the same as N2 to get us, so we can use that to get to P2. So let's first find N1. All right, so PV equals nRT. All right, so P is 1 atm. There I'll go blue. All right, 1 atm. Volume 2.5 liters. Remember liters. All right. N we don't know. R is 0.0821. That's constant. And then T is 273 Kelvin. Okay. Now let's divide. 0.0821, 273, 0.0821, 273. And when we solve for our N1, we get the answer of 0.11 moles. All right? So, good so far. So we know that N1 then is 0.11 moles. Okay, so good. Now, the key thing is, notice when we look at this problem, there's nothing about adding new gas or taking gas out. So we know that the number of moles of gas stays the same. The only difference is they're heating it up. Okay? So we know then that N1 equals N2. Okay? So we then know that N2, 0.11 moles as well. All right? So now we look at our stage 2 information. We have volume, so check. We have moles, check. R is constant, so check. T, we have 523 Kelvin, so check. So basically we're just left with solving for P, which is what the problem asks for. So let's fill out the information then. So we're solving for our P, so P is our variable. P, let's look, volume, 2.5 liters. N is 0.11 moles, so 0.11. R is our 0.0821. And then temperature is 523 Kelvin. Okay, I can't reiterate that enough. Kelvin. Let's see, 523. Kind of get a little tight over there, sorry. All right, and divide by 2.5 to solve for P. And we get, for our final pressure, when you do that out, 1.9 atmospheres. All right, so that's our answer for P2. And that's your final answer. So to recap, basically we looked at the problem. First thing we did was we realized this is an ideal gas problem. We then said, okay, there's two stages. Stage 1, our initial stage, and stage 2. We listed all the variables, and then we looked at the information given and filled it out. Filled out this chart of information. We used the information in stage 1 to find the number of moles. We recognized that the number of moles stayed constant, and so then we had only one variable left for stage 2, and we used the ideal gas law to find P2. Our final answer is 1.9 atmosphere, and there you go. Thanks for watching, guys.